Hello, and welcome to the National Agricultural Library's Ag Data Commons monthly webinar series. Today, we are going to be learning about data dictionaries. My name is Erin Antonoli, Knowledge Services Metadata Librarian, and I will be presenting this webinar today along with John Sears, Ag Data Commons Data Scientist. He'll be here to help answer questions after the presentation. We'll begin by reviewing what a data dictionary is, why someone might create a data dictionary, review several different types of data dictionaries, walk through some guidelines, instructions, and best practices for creating data dictionaries, and conclude with time for questions. I'm going to start off by explaining what a data dictionary is and why including one with your data is important. A data dictionary can simply be defined as a document that describes a dataset, database, or collection of databases. Another way of looking at this is to think of a data dictionary as a centralized repository of information about data, such as meaning, relationships to other data, origin, usage, and format. This can include names and descriptions of tables or entities and their contents, also known as fields. Other information a data dictionary might record is the type and length of each data element and the relationship between tables if it's describing a relational database. There are many reasons why data dictionaries are important. Data are valuable and often unique assets that should be properly managed in order to be accessible, understandable, and reusable into the future. Sometimes referred to as the Force 11 Open Data FAIR principles, data dictionaries play a crucial role in making data findable, accessible, interoperable, and reusable. I've mentioned the FAIR principles in quite a few of my past webinars, and if you've attended a webinar, talk, or other information session about data, there's a good chance you've heard this acronym mentioned before too. That's because it's important to consider these aspects of data management throughout the data life cycle when dealing with data, and people are more actively considering these principles when dealing with their data now. Data dictionaries can cover all four of these principles, but focus largely on making data more interoperable and reusable, because they provide more details and information about the entities and fields being represented in the data. Better understanding of the information contained in the dataset leads to ease of reuse and integration with other systems. Data become more interoperable and reusable if they're normalized. Normalizing data means you're making the content of each group of fields consistent. This can take on a number of forms depending on the nature of your data. First of all, if you want everyone responsible for creating records, as well as the data itself, to operate using the same measures and terms. If one person uses measurements in feet, another in inches, and another in meters, the files and records can't work together effectively until that information is all standardized. In a case like this, a data dictionary would serve as a blueprint for how data and record creators are expected to record their information so that everyone is on the same page. Likewise, field values should be consistent. Identifying any controlled vocabularies, authority files, or formatting that should be used helps ensure that all related records look and interact the same way. Imagine everyone uses whatever terms they want to describe a specific variable. Searching could be hampered and return incomplete results if everyone applied different keywords. A user would have to search every single variation of that idea in order to retrieve all the related records. Data dictionaries can identify controlled vocabularies, but can also outline acceptable content for a given field to keep values consistent and more easily searchable. Another example of using a data dictionary to standardize data and formatting presentation is use of decimal places in recorded observations. What if one investigator in a project installment submits data with accuracy to the 5th decimal place, but another submits data with accuracy to 3 decimal places? If the project needs a certain degree of accuracy, the data dictionary would specify this for fields, and investigators would know how accurate their data needs to be without over or under recording. This would also ease the burden on researchers consulting the data later on, since the accuracy level needs would be standardized and spelled out in the data dictionary. The data dictionary is helpful for facilitating reuse, but it is also integral for the data creators and catalogers to ensure interoperability of records and files. I've also presented this diagram of the data lifecycle in previous webinars. Managing data is an ongoing process, and metadata plays a key role in the life cycle. The data dictionary most closely falls under the Describe section because it is most strongly associated with metadata. However, a data dictionary at a program level created prior to the data creation could also facilitate the collection of data, since methods, measurements, and other data descriptions would be outlined ahead of time to guide data collectors in their task. In fact, looking at most of these steps in the life cycle, I could argue that the data dictionary does indeed help with some aspect of each process. In essence, the data dictionary is metadata about metadata. But, as you can see, without good metadata and a way to decipher what has been recorded, the rest of the data life cycle will break down. Before you create a new data dictionary, researchers and catalogers should determine if a data dictionary specific to their organization or previous projects already exists. If a data dictionary does not exist, follow guidelines consistent with your area of research that are already in place to create yours. Some data dictionaries can be generated automatically from a database, while others have to be created manually. Don't reinvent the wheel as you approach this process. We will review different types of data dictionaries shortly, so you have a better idea of where to begin based on your own situation. Data dictionaries should ideally be machine-readable. We went into more details about what machine-readable data is and how to create machine-readable data in a previous webinar that is now available as a recording. But it is especially important to make data dictionaries machine-readable. The main reason for this is that not everyone may be able to open or even want to open your data files depending on their size or what specialized software needs to run. But even if everyone can open your data dictionary, they will at least know the contents of your data package to know if it's worth their while to make the necessary time commitment or software additions and customizations. Even if they already have the necessary software, people might not want to spend time downloading and sorting through the entire data package, which could be quite large, if there's a chance it might not be useful for them. In some cases, the data files themselves are not easily searchable. Even if the search tool integrates a full-text search of all resource contents, column headers may be abbreviated or coded in a way that would not return in a standard search result. The data dictionary could potentially make the data more searchable. We also talked about avoiding obsolescence in previous webinars. If data is created with proprietary software, there may not be a workaround to avoid obsolescence, which is why we advocate for using non-proprietary file formats whenever possible. However, if for whatever reason you absolutely must present your data in a proprietary format, a machine-readable data dictionary would make the descriptions of your data available long-term, and let organizations, institutions, or individuals know if the contents they hold are worth converting or reviving through legacy software. In the next portion of our webinar, we will begin to review some different types and ways of creating data dictionaries and where you might encounter these various documents. Data dictionaries can be created manually, and we will review how to create one in a CSV format. They can also be generated automatically through certain types of database software, and we will review how to do this using Microsoft Access. And finally, many platforms offer templates to help users create data dictionaries. This is somewhat of a cross between manual and automatic, since the fields are already provided, but you need to fill them in. We'll look at what a template for ISO 19110 for geospatial data looks like, and the resulting feature catalog XML document it produces. First up, creating a manual data dictionary. If you're creating a data dictionary manually outside of a particular metadata template, CSV is likely the format you will want to use. CSV is non-proprietary and machine-readable, making it an ideal choice. The document you create should define the elements and variables used to record data, and include descriptions, measurements, and other information for data variables. This type of data dictionary is flexible in terms of subject and discipline, and accessible because it is created manually using spreadsheet software that most of us have available to us in the form of Microsoft Excel or Google Docs. And obviously, while the software can produce many different file formats, you want to save the finished document as a CSV so that it is machine readable. As I've mentioned several times now, creating a CSV document is one method of manually creating a data dictionary that would also be machine readable. A CSV document should be formatted as follows, and I'll show a visual of what this will look like in a minute. There should be no comments or aggregate statistics embedded anywhere in the document. There should be a single column header. The first row of the first file should contain the column names corresponding to the information contained in each column. Fields should be free of formatting and any special characters. For instance, numeric or currency cells should just be numbers without any formatting or non-numeric characters. This includes the use of color, bolded and italicized text, and other visual aids. Each cell should have only one piece of or type of information in it, and the format should be consistent within each column. Keep everything in one table on one worksheet page. Do not put multiple tables on a single worksheet or create multiple worksheets in a single file. These rules are necessary because formatting is not carried forward into CSV files. In addition, the inclusion of extra information like metadata and human-readable comments makes it harder for the computer code to parse and read the data through analysis and programming techniques. I mentioned the Tidy Data paper in our machine-readable data webinar, and I want to include a link here as well because it explains a lot about keeping data neat and understandable. A lot of those same principles carry over to manually creating data dictionaries. This is an example of what a CSV data dictionary might look like. Here, we can see the name of the data spreadsheet in the first column, the column headers contained in that spreadsheet recorded in the second column, and the descriptions of each field from the data resource files recorded in the description column here. If the values of a field are limited to a list of choices, those can be recorded in the Acceptable Values column. Each value should be listed separated by a vertical pipe character. I have also included other information in this document. including the data type accepted, character length, and whether the field is required. We offer guidelines and templates as a starting point for creating your own data dictionary, which can be found in the Ag Data Commons Submission Manual under the About tab on the Ag Data Commons. During the original airing of this webinar, we had a question about whether a project where the same variables repeated needed to keep listing them in multiple times in the data dictionary, or if one entry for each repeatable variable was enough. If your project examines the same exact variable across multiple studies or even multiple observations and the nature of the variable does not change, for instance, you are always measuring rainfall in inches daily, or distance in meters, or depth in centimeters, or weight in grams, and not some other variation, you can definitely make a master variable list of all the possible observations with the display name, description, data type, and so on. Many large projects use this approach so that each researcher can pull from the master list and be consistent with one another, while at the same time customizing their experiments or setups to only include the relevant information. In addition to providing a guide to the data, a data dictionary allows the data provider to remove any extraneous information from the data spreadsheet itself and instead include it in an informative format that is also machine readable if saved as a CSV. While formatting is a huge part of creating a CSV data dictionary, another important aspect to consider is the content itself. Some tips include using standard names for variables to support interoperability. We discussed the reasons for this earlier, and standardizing these variables now will save a lot of time and potential error that could occur if the values are normalized later on. Avoid local or colloquial names, since not everyone may use those terms or know exactly what they mean or refer to. Include strong keyword descriptions in this data dictionary. Keep in mind the most commonly used terms, or words users may search for most frequently for data like yours. This will help users find your data more easily. If your data is in spreadsheet form, a quick way to copy all the variables or field names from a data file into a data dictionary is to use the transpose tool in spreadsheet software. This tool allows you to copy a horizontal row and paste it into a vertical column. This is available in Microsoft Excel and Google Docs, and usually shows as an option in the paste function. If the transpose tool is not available in a regular paste menu, in some cases a right-click will provide a paste special menu where the transpose tool will be available. Next, we'll review automatically generated data dictionaries. Automatically generated data dictionaries will look and function quite differently from manually created ones. Like a CSV data dictionary, these documents define the variables, but will also define formatting and other database specifications. Unlike a CSV, this resulting document will often not be easily human readable. Not every database is capable of creating an automatically generated data dictionary. While data dictionaries from databases like Microsoft Access can be generated fairly easily, or third-party software might be used to generate a codebook to export in Markdown format, you may need to contact your systems department to see if a record can be generated from your database and how that could be accomplished. If you can generate a data dictionary, one huge benefit is that it is created automatically using a database export function. Less work on your part with fewer errors are always welcome. Generally, this resulting document is in a text or PDF format file. Text and PDF formats are generally non-proprietary. If you can generate a PDF-A document or another type of structured text-based output, then that would be machine readable, which would be another added level of functionality to your data dictionary. This is a screen cap of what an automatically generated data dictionary might look like. This section shows the properties of the database. Again, another view of the same data dictionary that shows more of the formatting. This document will record all aspects of the database in text form so that someone could, in theory, recreate the look and feel in addition to knowing what data is contained within. This is an example of a code book, which is a document that provides both an overview and description of the variables in a dataset. In this case, the original data being described is from an R database. Packages such as DataMade can be used to generate code books from R data in Markdown format, with information on each variable in the data frame. The document can then be rendered to a report in HTML, PDF, or Word. There are a lot of types of databases, and many of them have methods of generating data dictionaries without having to bother your systems department. I'm going to walk us through how to generate this document in Microsoft Access. Here are the steps listed out, but I will show them in some screen caps just so you can see each step. This slide deck and recording will be available after the webinar for anyone who wants to go back and review later. With your Access database open, navigate to the Database Tools tab. From there, find the Database Documenter button in the toolbar and choose it. This opens a window for the Database Documenter where you can choose which tables you want to include in your document. You can choose to include only certain tables or choose them all. The Select All feature lets you grab everything fairly quickly, which is a big help if you have a lot of tables in your database. There are also a lot of other customizable settings at all stages of this process, including the Queries and Macros tab, and the Options feature that lets you further customize how your document is generated. However, for the purpose of this demonstration, I'm just going to stick with the defaults. Once I have all my choices checked, I will choose OK to generate the document. That brings up a print preview dialog showing the document, and from here you can choose the format, orientation, and a lot of other customizations to make this document look the way you want it to from the toolbar at the top of the interface. When all those choices are made, choose either the text file or PDF option from the toolbar at the top. You can export in a variety of formats, including Microsoft Excel, text, and PDF. But remember, text documents and PDF files are non-proprietary, while Excel is a proprietary and less desirable format for this type of document. Choosing text file from the toolbar will bring up a dialog asking you to choose the encoding option. I've stayed with the defaults here. And after choosing OK in this step, you will specify a name for the file and a location to store it. Complete those steps and you'll have a text format data dictionary from your database. Lastly, we'll review creating data dictionaries using a web-based form. Some data dictionaries can be created through a user interface that provides a form for users to fill out and complete various sections of the document. Users don't have to worry so much about formatting column headers and rows or other setup like they do while creating a CSV data dictionary manually, since the document is generated based on the user's input. It's not fully manual since the user does need to enter content, but the formatting aspects of the process is automatic. The Ag Data Commons is moving toward this type of setup for our own data dictionaries. So with newer versions of our platform, we may see this approach become more common for the data that we maintain. ISO 19110 on NAL's GeoData platform is an example of this form-based data dictionary, or feature catalog as it's called in that standard. This data dictionary standard is used to define metadata in ISO 19115, which is specific to geospatial data. Here's a little background on this particular standard as defined by the ISO 19115 and ISO 19110 standards themselves. ISO 19110 defines the methodology for cataloging feature types. This document specifies how feature types can be organized into feature catalog and presented to the users of a set of geographic data. This document is applicable to creating catalogs of feature types in previously uncatalogued domains and to revising existing feature catalogs to comply with standard practice. This document applies to the cataloging of feature types that are represented in digital form. Its principles can be extended to the cataloging of other forms of geographic data. The feature catalog is applicable to the definition of geographic features at the type level. This document is not applicable to the representation of individual instances of each type. It may be used as a basis for defining the universe of discourse being modeled in a particular application, or to standardize general aspects of real-world features being modeled in more than one application. So, through all that, we see that while this standard calls its documentation a feature catalog, this serves a very similar purpose as a typical data dictionary. More often than not, a template must be used to create these documents because they are more complex and follow a predetermined standard that requires validation. The final product is stored in XML format, which can be displayed on a wide variety of platforms and is machine readable and obsolescence-proof. Here's a screen capture of a feature catalog I was creating in GeoData displayed as XML. Feature catalog format, like most metadata, is XML format as standard, which is machine readable. And here we can see how NAL's GeoData interprets this feature catalog XML file. Because XML can be displayed a wide variety of ways, the way it looks will depend on the interface that is interpreting it. The information itself will never change, but will be ingested into the system and displayed according to the styling of the host system. In this case, you can see the attribute name and description, along with the list of values possible for that attribute if it is a controlled vocabulary. For instance, here we see region has 6 possible values, all with their own codes and definitions. For attributes, that can house any values such as identifier, a description, and data type are sufficient. With geospatial data such as maps, shapefiles, images, and other non-text-based data, a robust data dictionary along with an excellent metadata record will help a database and data set be more findable, accessible, interoperable, and reusable into the future. In this case, for a researcher looking for information about a particular state, a data dictionary would not only be helpful in figuring out if a found record is relevant, but would provide a key to finding more relevant information through other variables the document outlines. In this particular case, someone who wants to find more information on Oregon would know to look in the datasets that specify their region as Pacific Northwest Region, Region 6. And we can also see this region has a code of R06, which may also lead to more results in a targeted field search. In conclusion, today we learned what a data dictionary is and why data dictionaries are important. We reviewed different types of data dictionaries and walked through methods of creating data dictionaries manually as a spreadsheet, automatically from a Microsoft Access database, and from a form using the ISO 19110 template. Before we open up for questions, I want to share a few links that you might find helpful regarding data dictionaries and our contact email for any further questions. The first link is to the Ag Data Commons news page, where we list all upcoming and past webinars. Past webinars are updated with a link and password to view the recordings, so you can check out some of our other topics on machine-readable data and data management plans, among other topics that might be of interest. This is especially relevant to this webinar because some of our past webinars will give better insight into the ideas presented today. The second link is to the Ag Data Commons submission manual, particularly the data dictionary section of our manual, where we have several chapters on data dictionaries. We also include a blank template for users to copy when creating their own CSV data dictionaries manually. The third link is to frictionless data software, which John mentioned during the question and answer portion of the original webinar airing. There's a lot of information here about specifications and software to help create data in machine-readable formats that lend themselves well to data dictionaries. The last link is the Ag Data Commons Curator inbox email address, where you can direct any questions. That's nal-adc-curator@ars.usda.gov. And now we will open up for questions.